Hello everyone, welcome back to your channel Physics with Oliver. Today we will discuss another numericals from NEET 2022. Okay, at first read the problem. If you have not subscribed the channel yet, then please subscribe the channel and press the bell icon. Okay, now read the problem. A shell of mass m is at rest initially. If it explodes into three fragments having mass in the ratio 2:2:1. So at first there is a body whose mass is m and the body is at rest. Now the body is exploded in three portions and the ratio of their masses is 2:2:1. That means these two masses are equal and this is small. Okay, this is the lighter one. If the fragments having equal mass, that means the first one and the second one. If the fragments having equal mass fly off along mutually perpendicular direction with velocity v. These two masses, first one and second one, suppose we are giving name, these are m. These are m1, m1 and this is m2. Okay. These two equal masses are flying off along the mutually perpendicular direction with velocity v. This is going in this direction and this is going in this direction with velocity v. Okay, this is m1 and this is also m1. Then the speed of the third fragment. We have to calculate the speed of the third fragment or the lighter one. We have to calculate this. Okay, so the question is clear. At first we have one mass whose mass is small m and that mass is at rest. Then the mass is exploded in three parts. The ratio of the masses of the fragments are 2:2:1. That means the first two masses are equal. So we have taken m1 and m1 and the third one is the lighter mass, that is m2. And the first two masses having equal mass are going with velocity v in mutually perpendicular direction. Now we have to calculate the velocity or the speed of the lighter mass. Okay. Here it is given the ratio of the fragments of the ratio of the masses of the fragments are 2:2:1. So let us consider that first m1 mass is 2x, m2 the second one is also considered as m1 as the masses are equal, so m1 is also 2x and the third one is x, right? So the total mass m is equals to m1 plus m1 plus m2. So m is equals to 2x plus 2x plus 1x. So this is 5x, right? Now we will do the problem by using conservation of momentum. Okay, at first when the mass was intact, m, that is equals to 5x, the velocity of the body was 0 because it is said the body is at rest, right? So the velocity was 0, so the initial momentum is equals to 0. After the fragmentation, the velocity of the two bodies are mutually perpendicular to each other for this 2x mass and 2x mass, right? And we don't know the velocity of the direction and the magnitude of the velocity of the third mass. We don't know this. We have to calculate this, right? So from here we can write that P from conservation of momentum, we can write P initial equals to P final, right? We can write this from conservation of momentum. Hence, Pi is equals to P1 plus P2 plus P3. P1 is the momentum of the first fragment, P2 is the momentum of the second fragment, P3 is the momentum of the third fragment. Okay, we know the initial momentum was 0 because as the body is at rest. Now P1 and P2. This is the resultant of the momentum of these two, right? So from here we can write this P1 plus P2 plus P3 is equals to 0. So from here we can write that P3 is equals to minus of P1 and P2, right? In vector notation we can write this. Now here, when we are taking the magnitude of the momentum, we can write that P3 is equals to the resultant of P1 and P2 momentum. Okay. Now from here we can see that P1 momentum is equals to mass into the velocity, and P2 momentum is also equals to mass into the velocity, and angle between them is 90 degree. Okay. When two vectors are acting perpendicularly, the resultant of the two vector is equals to a square plus b square, right? Suppose this is a vector and this is b vector. Then the resultant will be, the magnitude of the resultant will be root over a square plus b square. So here we can write P3 is equals to root over P1 square plus P2 square, as the angle between P1 and P2 is also 90 degree. P3 means the momentum of the lighter mass, that is x into, we don't know the velocity, that is v2 we have taken, right? And we know the value of P1, that is 2xv whole square plus 2xv whole square, right? So xv2 is equals to root over 2 4x square v square. So root over 8 x square v square is equals to xv2. So xv2 is equals to root over 8 xv. X cancel out. v2 is equals to 2 root 2v. So the velocity of the lighter mass, lighter fragment is 2 root 2v. This is the correct answer. Now I am showing the actual scenario. What is happening here? A large mass was there. The mass was 5x and the velocity of the mass was 0. The body is at rest. Now the mass divided in three portions. One is 2x, another is 2x. These are the masses, and the third one is 1x. Okay. These two bodies are moving with velocity v, mutually perpendicular direction. The angle between them was 90 degree. So the resultant momentum of that body is along this direction. This was the resultant momentum PR. Okay. So the third body should go in this direction with minus PR velocity to maintain the total momentum 0. Here the initial momentum was 0. So the final momentum should be 0. Right? If the third body that has mass 1x is moving in this direction with this momentum, then the total final momentum will become 0. Right? So this PR minus is the final momentum of the lighter fragment. This is the actual scenario. And here we are just calculating the magnitude. So we are not considering the direction. The magnitude of this resultant momentum is equals to the magnitude of this momentum of the lighter fragment. I hope you can understand this. If you have any doubt regarding this problem, you can ask in the comment section. Thank you everyone.